Hey everyone, welcome back after our short break. I'm Lauren Sichterman and I'm coming to you from Madison, Wisconsin. Thank you so much to those of you who have tuned in and engaged with us so far today. I'm so pleased to introduce you to our next presenter, which is Sam Richard. Sam is currently working at Google to help companies build and deliver their web applications for Chrome and ChromeOS. Better known as SnugUg throughout the internet, Sam is a developer with design tendencies and a love of building open source tools. He geeks out on content strategy, team process, and cultural transformation. Sam's social media feed, though, is mostly food, which, as his MC, it was my obligation to check out. I have to say I'm excited for Sam's session, but I'm also starting to get really excited for lunch. But don't go anywhere. It's my honor to welcome you to Sam's session, Building Progressive Web Apps, or PWAs, for everyone. Let's turn it over to Sam.
Thank you. Let's get started. Hi, everyone. My name's Sam. I'm here from Google, and I'm here to talk about building progressive web apps for everyone. On August 12th, 2020, myself and a cross-functional team launched ChromeOS.dev, our one-stop online home for all things Chrome OS. We launched in 2 languages, English and Spanish, with a site that was fully accessible, fully responsive, super fast, and could be installed and used offline. It took almost a year of planning, development, and content creation, but in the end, we launched a progressive web app that can be used by everyone. To get there, though, we had to change how we thought about design and development and how we did both. We didn't start out with a list of specific things we needed to do to make our site work for everyone, but we wound up finding that what we were doing fell into 3 categories. First, it needed to be fast. Having a site that starts fast, stays fast, and has a small payload means it can be accessed by more people more often. It can have accessibility implications too, reducing cognitive load required to stay on task. Performance is key to having users be successful with your site. It needed to be usable. Users interact with your site in lots of combinations of lots of different variables. Making sure it works just as well with only a keyboard and a phone as it does for a touchscreen on a desktop and everything in between is critical to providing a usable experience for everyone. And it needed to be understandable. In the end, users come to your site for its content. So if they can't understand it, they're not going to use it. Architecting your site and its content so you can create, display, and deliver content to your users, meeting them where they are, is key to having your experience understandable. To accomplish these 3 things, we needed to embrace automation, leverage new tools and techniques, and build new personal and team habits. A site built for everyone first needs to load for everyone. Our thinking on performance comes back to the Nielsen-Norman Group's seminal research on website response times and short-term memory and web usability. In it, NNG talks about why speed matters. Humans have very real cognitive limitations, and humans want to feel in control. From these, they discuss 5 response time limits for humans. The first is below 100 milliseconds. This feels instantaneous, and it feels to us like we're in control. Up to 1,000 milliseconds, users can sense a delay, but they still feel in control. Between 1 second and 10 seconds, users feel at the mercy of the computer. Beyond 10 seconds, they start to think about other things, making it harder for their brains to get back on track, and that they're no longer in control. And then after about 20 seconds, whatever chunks of information humans have in their short-term memory, they start to fade. Rail is a performance model developed by Google to take some of these human limitations and build a user-centered performance model for us to think about performance. And there are 4 aspects of Rail, and their user-centric goals are response, how long it takes to visually acknowledge a user's input. The goal is to do so within 100 milliseconds, to feel instantaneous. Animation. Humans are exceptionally good at tracking motion. We dislike it when animations aren't smooth. Animations include not just moving elements, but scrolling as well. The goal is to produce each frame in 10 milliseconds or less, or short of that, aiming for visual smoothness as users notice when frame rates vary. Idle. Tied closely to response, idle recommends chunking work done while users aren't interacting with your page to 50 millisecond chunks in order to give the best chance of being able to respond in time. And then finally, load. How long it takes to deliver content and become interactive so users can use your site. The goal is to do so in under 5 seconds for your users' average device power and connection speed. Or not knowing that, mobile powered devices and average mobile device speeds. We took a 3-pronged approach to ensuring that our site started fast and stayed fast. We automate image best practices so that contributors didn't need to think about them. We leverage new tools and methods to build and deliver just the JavaScript we needed quickly. And we created a rel-based performance budget with Lighthouse to check our work. Automating best practices. When it comes to best practices, we relied on a single guiding principle. Make doing the right thing the easy thing. As much as we could, we wanted to ensure that we met our content creators and developers where they were, with what they already knew, and automate best practices around that. We started with image handling, as it has one of the largest impacts on overall site performance and weight. While a 1 megabyte image will have a vastly smaller impact on performance than a 1 megabyte JavaScript file, making sure the right image is served at the right time is still an important aspect of load performance. Because images may be rendered from a number of places, Markdown, metadata, templating, HTML, we didn't want the burden to be on our authors to remember to do everything right every time. Instead, we built a post-processing step into our workflow to make doing the right thing as easy as properly formatting your image tag. For SVGs, we simply optimized the file and lazy loaded it in. For PNGs and JPEGs, we cut multiple image sizes based on a scaling factor, optimized each size, and produced corresponding WebP images, ultimately replacing the image tag with a full picture element, including all sizes and formats, and lazy loaded that in as well. For GIFs, we went a step further. Animated GIFs have a much larger file size than their corresponding video due to how videos are encoded, and can't be streamed like videos can. Because of this, we actually transformed each GIF into an MP4 video and set it up as a silent, looping, auto-playing video. If you happen to be using 11D, like we were for our site, we open sourced our solution for doing this into a node module, 11D plugin local responsive image. JavaScript has byte for byte the largest impact on all 4 aspects of the rail performance model. So we knew we needed to send as little of it as possible down the line. To accomplish this, we created what we wound up calling a hub and spoke JavaScript model. Hub and spoke is a distribution paradigm borrowed from the world of transportation, especially airlines. It's characterized by a central node where all other nodes traverse through or originate from. For us, this meant instead of sending one large JavaScript bundle to our users, we sent one small JavaScript file down that acts as a sort of coordinator for the rest of our JavaScript. Our hub file determines what features are required for any given page. Then, using ES module dynamic imports, sends off asynchronous requests. Those files all then export classes to be used, but don't run code themselves. Once loaded, the hub file executes the loaded classes as needed, which in turn may dynamically load other ES modules. For production, we take it a step further and tree shake our source, removing unused exports and compiling into multiple small bundles, with commonly interconnected files being bundled together. In our case, we used rollup. While this model does have a single point of failure, it can effectively scale to lots of modules and won't bring our user experience down if one of them fails to load. It also means we can get interactive faster because ES modules are deferred by default, meaning they won't block the HTML parser. The initial JavaScript load is kept very small, in our case, under 2.5 kilobytes. We know we'll ever only use or load the code that's absolutely required for the page the user is viewing. And we can differentially load additional code, not only based on if a feature is required, but on the importance of the feature, even deferring non-critical resources until idle availability. When combined with our service worker, where we preload the individual JavaScript bundles without affecting our site loading, we're able to use the hub and spoke model to quickly get a user interactive with our site by loading only what's needed when we need it and pulling it all in quickly from cache without additional network requests. And then performance budgets. We created a performance budget for our site and used our continuous integration system to test every change to our code base against it. Lighthouse is a tool that can be used to run a number of audits for your site and comes with built-in audits for performance, accessibility, best practices, SEO, and progressive web apps. You can run it through Chrome Dev Tools, through Node, or as part of your continuous integration pipeline. For all built-in audits except PWAs, you're given a score from 0 to 100 based on weighted results of each audit run. Lighthouse's built-in performance scoring is based on weighted measurements of key performance indicators, which for us aligned well with what we were looking for from the Rail model. We allowed as low as a 90 and ran our site against an average mobile device speed and power. Because there was some variance in testing, we ran each test 3 times and we ran it against a couple of representative pages across our site. If changes failed our build would fail and we'd get a report showing what went wrong. Everything was great. Then, during what we thought was a routine upgrade to Lighthouse 6, all of our tests started failing. Lighthouse 6 changed how performance audits were weighted and what measurements were performed. A new holistic set of measurements for user experience called Web Vitals were introduced. A subset of them, the core Web Vitals, reflect real-world experience of a critical user-centric outcome. While they will evolve over time, the current set focuses on 3 aspects of user experience: loading, interactivity, and visual stability, and have the following metrics. First is LCP, or largest contentful paint. It measures loading performance, specifically the render time of the largest image or text block visible within the viewport. Previous performance metrics like first contentful paint, first meaningful paint, and speed index are all still good things to track, but they either don't necessarily reflect useful content for users or are complex and hard to explain. Ideally, you want this under 2.5 seconds, and anything above 4 is considered poor. The next is FID, or first input delay. It measures interactivity, the time from when a user first interacts with a page to the time when the browser is able to begin processing event handlers to respond to that interaction. Less than 100 milliseconds is good, and anything above 300 milliseconds is poor. Finally, there's CLS, or cumulative layout shift. It measures visual stability, and it measures the total layout shift for a page across its lifespan. Layout shifts occur anytime a visible element changes its position from one rendered frame to the next. It's calculated by multiplying the percentage of the viewport affected, called the impact fraction, and the largest distance any moved element has moved relative to the viewport, called the distance fraction. A CLS below 0.1 is good, and above 0.25 is poor. So, what happened to our performance score? There was an automated optimization that we had done, automatically inlining CSS for elements in our viewport into our HTML and lazy loading the remaining CSS, and it was causing problems. We had originally done it to boost our first contentful paint score, and it did that really well. Unfortunately, it also wound up having the net effect of causing a large cumulative layout shift for many of our pages. After some experimentation, we found that removing this optimization wound up removing the CLS problems at the expense of blocking our site rendering a little bit, reducing FCP. Fortunately, though, it wasn't enough to have a real impact on the largest contentful paint. As a bonus, it made all of our pages lighter weight by stripping out almost 14 kilobytes of CSS from each page. By leveraging automation and continuous integration, we were able to create and stick to a performance budget. When the performance budget got smarter, we were able to leverage both again to fix our problems and validate our work. With our site fast, we also needed to ensure it was usable. For us, usable meant that all content and all features of our site could be accessed by all users, regardless of the combination of device, input, and accessible technology being used. To accomplish this, we needed to change how we thought about the relationship between design and engineering. There are 2 new habits we built in order to make our site usable for everyone. Reaching new people required new habits around development and testing to ensure success. And while our design started in static sites, tools like Sketch or Photoshop, we found we needed the full expressive medium of the web to design a great experience for everyone. Much like performance is much harder to build a site or feature and then, once everything is done, go back and make it usable. In order to save us a ton of hard work at the end of our project, we made a commitment to start usable and stay usable. But we need to introduce a new habit, backed by a little automation, into our team: staging testing. Our continuous integration system was already set up for running automated tests, but now we found ourselves needing to run manual tests too. So we expanded our CI system to build a staging environment for each change request and report it back as a comment for our code reviewers to use as a test ground. We use the staging environment not only to test the changes in general, but also specifically to test different input types like keyboard only, and taught our team the basics of assistive technology like Chromevox and VoiceOver, so we could test not only if a site was visually correct, but if it was tactilely and audibly correct too. Even with this testing though, some aspects of usability are more of an art than a science. A month before our launch, our ChromeOS accessibility team reached out to see if they could test our site. For most projects, this would be a source of some dread. What are they going to turn up? Will we need to delay launch? How much more work are we going to need to do? But for us, we were excited to work with them. We had been vigilant with our new usability habits, and were confident things would be okay. Talking through what we had been doing with the team, they were impressed. We had all of our bases covered, and most things they'd normally look for, we had already done. Even so, they went back, tested our site, and came back to us. The results were mostly what we were expecting. No major issues, a couple of small tweaks here and there, all things we could fix in basically one change request, except for our main menu. Now, it's not that our main menu wasn't accessible. Rather, they thought we could provide a better overall experience with some changes. Our menu has a combination of links to other sections and buttons that open up drop-down menus. Our original design entirely hid the drop-down menus, visually and for assistive technology, until a user activated the parent menu, at which time it became visible. AT users often navigate a site using built-in shortcuts to scroll through a site's links, and our solution didn't allow main nav links to show up in this list. We wound up prototyping a solution that visually hid the drop-down menu, made them unreachable by toggling their tab index, but still allowed them to show up in an AT's link list. We were excited about this as a potential solution. We hadn't seen a menu built this way before. After some testing and discussion, though, we all decided this presented a new problem. Low vision users who use assistive technology may find that there's a mismatch between what they see on screen and the spoken feedback, that there are links available, and that may make the user experience feel confusing or make it feel broken. So we went back to our original design. It's not that we went back to it because it was better all along, but rather we went back to it because after bringing in experts, prototyping, testing, and trying it out, we found that the original design's trade-offs were just as good or good for our needs as opposed to our prototype's design. The second new habit we built was around how design and engineering worked together and was buoyed by some new tech used in new ways: designing in browser. Designing in browser gets a bad rap. It's often thought of as requiring designers to learn web development and write production code, while simultaneously limiting creative freedom by constraining designers to what can be done or done by them on the web. We instead took designing in browser to be an opportunity for design and development to more closely collaborate, almost like pair programming, building on each other's strengths and sharing ideas and constraints to create a better, more usable result than would be possible with either on their own. Our process went something like this. Our designer would start by designing two views for each page, a small view and a large view. We would consider these as starting points for our work, not the final designs. We break these pages down into components, individual blocks that contain content, and layouts, how those blocks are arranged on the page. For both, We try and figure out if we already had one that we could reuse, or if we needed to create something new. We then go and build them. When we did, we intentionally built them separate from each other. We would leverage Flexbox's ability to swap from inline to block based on element size to make components that could respond to how large they were. We used, sparingly, resize observers to change how components functioned based on known CSS changes, letting us move components around without needing to write multiple media queries or share them with JavaScript. And we use CSS grid and content-based units like the CH unit to build layouts that flex not only to the viewport, but also to the content in them. Finally, design and development would sync back up, leveraging the live preview builds we had to work together to tweak the components and layouts between the small and the large sizes, bouncing ideas off each other as we went. And that turned out to be super important. In the 2 months since launch, we have had 2,874 unique screen resolutions, with the top 10 screen resolutions accounting for just over 50% of total users. There are only 4 screen resolutions that account for more than 5% of all users. And screen resolutions with more than 5 users ranged from 300 by 426 all the way up to 5120 by 1440. Coupled with interesting findings like 1920 by 1080 coming back as mobile, tablet, and desktop devices, it showed us the importance of being truly flexible and not making functionality assumptions based on screen size. All this was imperative to build something truly usable. Fast and usable, we finally need to ensure our site was understandable. This required us to make it available across multiple languages. It required us to internationalize our site. Just like when making our site fast, it had to be understandable. We built some automation and leveraged some new technology to do so. In a single language site, the content is the content. In a multi-language site, content is really its structure. With content in multiple languages, you need to be able to serve the right language to the right user. For us, service workers to the rescue here. Because we were localizing our site into multiple languages, our thinking shifted from content as a series of pages to content as a part of a larger structure and how that structure fits together. When working with content management systems, it's pretty natural to structure content with fields and enforce what kind of content can go where in those fields. Contents that's used and structured similarly are often given a name to identify them. These are content types. But what happens if you aren't using a content management system? Our site is built with a static site generator, so we needed to come up with a way to structure our own content. With content mostly written in Markdown, we're able to store additional fields in front matter. But there's no built-in way to enforce a given structure to that front matter. When we first started out, our models were somewhat loose, our front matter all over the place. But then we stumbled upon an idea. What if we linted our content models? Using JSON schema, the AJV, remark, and remark lint node modules, we built content models for all of our content stored in Markdown, down to what tags were allowed. Then we hooked up this linting to our CI system, and we turned otherwise free-form Markdown into structured content that we could then work with across our codebase. Combined with storing microcopy, the words and phrases used throughout our user interface, in similarly structured files, we were able to build a new habit, moving away from hard-coding strings and designing and building one page at a time towards creating systems of content, design, and code. Structuring our content meant that we could then leverage some work we had already done to make our sites fast and usable to make all 3 even better. Combined with our component approach, we were able to standardize input and output arguments, making all components across our site more flexible to what they accepted. Combined with our hub and spoke JavaScript model, we could load only the individual translation files we needed for only the components we needed when doing client-side rendering, like messaging to our users. And combined with our content-aware responsive design, we could have our UI flex for different languages without needing to create language-specific breakpoints. Being able to think about our content as a system instead of pages made our entire site more flexible, making it easier for us to localize and therefore make it understandable for more of our users. But we still needed to serve the right content to the right users at the right time. There are lots of solutions for serving right localized content to the right user, but for us, we chose to take a relatively new technology, service workers, and leverage them in a new way. There are three high-level ways of determining what localization to serve to users. Get their location from their IP address, use the accept language header or navigator.languages to get a user's set preferred languages, or have an identifier in the URL. Often, systems wind up combining 1, 2, or all three when deciding what localization to serve. After we investigated, though, we found enough issues with the first tool to rule them out for us. First, a user's preferred language doesn't correlate with their physical location, which is what IP address provides. Second, actually figuring out location from IP address is difficult, generally unreliable, and may actually prevent the site from being crawled by search. And then finally, preferred language is often never explicitly set, and more often than not defaults to English, making accept header unreliable. Because of this, we wound up using identifiers in our URLs. There are three common patterns for building identifiers into URLs. The first is to provide different TLDs, for example, example.com or example.de or en.example.org and ja.example.org. The second is to serve localized content based on URL parameters. So example.com query lang equals en and lang equals fr. And then the final is localizing subdirectories, example.com/en and /es. We decided against different domains as they're not a good fit for progressive web apps. Every domain, including TLDs and subdomains, are considered different origins and would effectively require a separate PWA for each localization. We also removed URL parameters as an option because it's difficult for a user to recognize, can be easily deleted, and can run into a number of analytics and management issues. So we went with subdirectories. Our site is serverless, so we needed a solution that could support that. Because service workers are effectively in-browser proxy servers, and when combined with our subdirectory identifier, we can do localization redirects easily, consistently, and without a back-end server. It works like this. When a request comes in, we peel off the locale subdirectory, check it against the user's stated language and/or region preferences. If the user doesn't have a preference, we let them continue on, assuming they got the link from somewhere that had pre-filtered for us, like social media or a coworker, and set that as their preference when they arrived on the page. If they have a preference and it matches, we again let them continue on. But if they have a preference and it doesn't match, then from the service worker, before we make a network request, we do a 302 redirect to the same page, but in their preferred localization. For anything that's not a content page, we simply let the request go through as normal. A relatively small bit of service working code, combined with the right localization strategy, makes our site quick to figure out what localization you need and make our site understandable for you. So, how do we build a progressive web app for everyone? We made it fast. We automated image best practices for optimization and delivery, created a hub and spoke JavaScript model, leveraging ES modules, and automated checking performance budgets to keep us on track. We made it usable. With the help of automation, we built new habits around usability and assistive technology testing on staging previews, and changed our habits around design, co-designing in browser and leveraging new CSS tools like Grid, Flexbox, and content-based units. And we made it understandable. We changed our habits around hard-coding content and created systems of content we could automatically lint, and leveraged new use for service workers to automatically detect users' preferred localizations. Fast, usable, and understandable. These principles guided us to making a PWA for everyone, and I think they can help you do the same. Thank you very much. I'm Sam. You can see some follow-up links at my Twitter at twitter.com/snugug. Thank you.
Thank you so much, Sam. One thing I think is particularly interesting is the feedback threshold.
Sorry, are you still there?
Oh, can you hear me?
Hey, Sam, can you hear us?
Can you hear me? Can you hear me?
Uh-oh, I think I've lost you.
I can hear you, Lauren. So, Lauren, can you hear me?
I can, yeah.
Okay, awesome. Well, you know, I loved, Sam, what you talked about and bringing up Norman or Nielsen and Norman Group. So I'm Sandra Maples. My background is user experience and product management. And I love the fact that you are embracing really the technologies and using user experience and guidelines to help really provide that user experience that everybody's looking for.
One thing, maybe as we try to sort out those technical difficulties, I'll mention one thing I found that was particularly interesting, which is the feedback threshold at which we feel at the mercy of the computer. And I've definitely felt that as a user dealing with slow response times. But then it got me thinking that in many ways we really are, especially this year, always at the mercy of our computer. So making that a seamless experience for everyone is really important. Can you hear us now, Sam?
I don't think you can. Well, I think, Lauren, you're absolutely right. I mean, a year ago, even 6 months, well, 9 months ago, who would have expected that we would all be on this session from home? And the technologies that we have in our homes are so different from home to home, and compared to what we experience at work. And even at work, there's always somebody that you can talk to from a technology perspective to kind of help you iron out things like somebody not being able to hear you on a video. So I think as developers are really looking at their code, testing, and really thinking about the fact that sometimes when we create solutions, it's not necessarily going to be used in the environment that we expected.
I have a couple follow-up questions, but I'll make sure that these get shared with him and that he can maybe check out his Twitter at Snugug, SNUGUG, and we'll have him follow up with some questions there.
Sounds great. Well, we're a little bit early, but I'm going to start talking a little bit about our next speaker. So Anuradha is coming to us from India. And what I'm excited about with her conversation is it really feeds into the whole user experience and accessibility and usability of websites and development. And she is a wealth of knowledge. She's been a developer for 7 years. And about a year ago or so, she started to realize and started to learn more about accessibility. And once she started to learn more about accessibility, she really became passionate about it and created a website, which is a phenomenal resource for all of us. And I really encourage everybody to take a look at her website, and that we'll have that available. But I would say this group is really a phenomenal group of individuals. Connect with people on LinkedIn, connect with them on Twitter and other social media platforms, because really the products that we all build, and I'm not a developer, so that you all build, but I'm the one that sometimes sets the vision, is about the communication and people working together. And I think that's the common message that's been really exciting for me. What do you think, Lauren?
Yeah, I am really looking forward to hearing your next talk. I haven't had a chance to look at the schedule yet, so it's perfect that they are going to flow so well into each other. I'm